Okay, so for this video, I'm going to take a look at the sum and difference of cubes. This is a specialized version of the factoring theorem, sometimes known as the factoring theorem. I'm sure it has other names. But essentially, that if you are given something that looks like this, x to the n minus a to the n, you are always guaranteed that x minus a is a factor. What's left, it may not look pretty. So since you're guaranteed that x minus a is a factor, you could long divide and then find out what this has to be. For what we're going to do is I'm just going to lead you through the cubes. And so this is how it goes. Let's say that I have a cubed x cubed plus b cubed, and I want to break that down. Well, the way that I do it is I start off and I gather up a binomial and I gather up a trinomial, and I really accentuate the fact that I'm going to get something that's larger. All right, so here we go. And you can verify this by remultiplying it. What did you cube to get the first term? And that was a and x. What did you cube to get the second term? B. Everything else from here is built off of this binomial. So if I build it, I square the front to get the front. This is a squared x squared. I square the back to get the back. So that's b squared. And then I multiply to get the middle. So this is going to be abx. And then I have to put the signs in. Now, I do my signs separately because I have a little saying that goes about it. But you can certainly put the signs in as you go. You're just going to have to remember that the signs don't all end up being the same. So, and they don't end up necessarily, at least as far as it looks here, following a pattern to speak of. Now, if you look at the factoring theorem, there is a pattern to the signs. It's just not necessarily easy to memorize. So here's my little saying. Most people decide that when change happens, it's bad. What I'm going to suggest is that you keep change positive. And the reason for that is because that's what follows the signs. So if I put these signs in, then I keep the sign that I started with. So looking back at the original sign, I keep it in the binomial. I change it in the next one, and the last one is always positive. And that's it. That's how it works. Now the wonderful thing is that this whole thing still works with subtraction too. So let's do a few examples. And by a few I mean probably two. Let's take a look at let's take a look at one that doesn't exactly just fall out. So let's take a look at 54x cubed, and we're going to subtract off 1458 y cubed, and we want to factor that out. Okay, well, step one, is it in order? And by order I mean look at the exponents on the variables. Do they decrease as you move from left to right? And x is listed first, so let's talk about x first. So x, and it goes to cubes and then nothing. So it does decrease as you move from left to right. So we're good. Step number two, we need to factor out the greatest common factor. So let's do that first. 54 and 1458 share a common factor of 2, so let's at least pull that out, and then let's see what we have left. So this is going to be 27x cubed, and then minus 729 y cubed. All right, you might be wondering, it's like, okay, well, I couldn't do that in my head. That's fine. So what you're going to do is you're going to decide that both are even numbers, pull a 2 out, and then divide each of these terms by 2, and then put that result back in the parentheses. So just take your calculator, say 54 divided by 2, and the answer is 27, so it goes in the parentheses. Same way with the 729. Take 1458, divide by 2, and then you're going to get 729. Well, my students have a chart that I force them to make that has x, x squared, and x cubed. And the reason for this is that if you don't recognize 729 as a perfect cube, you may ultimately think that this is it and it's not factorable. Checking this for perfect cubeness is not exactly easy. So here we go. If I have 1 through 10, so 2, 3, 4, blah, 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 then this is going to be 1, 4, 9, blah, 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 blah. This is going to be 1, oh, not the line, silly, 8, 27, blah, 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 blah. Well, at 9, this becomes 81, and 9 cubed is 729. So I go through my questions then. The 2 comes with me. This is part of my third step. Specials. If I can use one of my specials, life is good. If I can't, that's fine. Now, one of the things I didn't mention up here is that you're not going to be able to factor this trinomial. Don't even bother. It can be factored, but most of the techniques that we would use to factor that are not typically taught at this level. So this level is what I'm thinking of as beginning algebra. If you're in a more advanced algebra class, then sure, perhaps they teach you how to do that. Right now, we're not going to go into that. So we're checking for specials. So we look at this. 27 is a cube. 729 is a cube. It's the difference of cubes. We're good. We can go ahead and factor this out. And so I create a small one and an exaggeratedly large one. What did I cube to get 27? Well, it looks like I cubed 3. And what did I cube to get x cubed? X. What did I cube to get 729? 9. What did I cube to get y cubed? Y. And now I square the front to get the front. So 3 squared is 9. And then x squared. I square the back to get the back, or 81y squared. I multiply them, so 3 times 9 is 27. And then xy to get the middle. And finally, I keep, and so this was a negative to start with, so I keep, I change, and the last one is always positive. And that's its factored form. That's it right there. So when you're talking about the sums and difference of cubes, it's really not that bad, but it's very much a memorized thing. I don't recommend that you just sit there and try to memorize everything that I do. More just work through it. So work through a few hundred of them, and you'll get it, as well as memorizing the values in the x cubed column. But again, just make this little bit of a chart. It only takes about 5 minutes to sit down and make the chart, but then you can just check these. So when you're checking these, 729, I'm looking in my x cubed column to see if 729 exists. If it does, it's a perfect cube. If it does not, then there's going to be a perfect cube before it and a perfect cube after it, and it'll fall somewhere in the center. If that's the case, I cannot use the sums and difference of cubes. I have to do something else. So this is just a whole lot of tricks, in a sense, to kind of make your factoring experience a little bit nicer. I said a little bit nicer. Some people are just going to struggle with it, and that's fine. It's more important that you understand the structure behind it, so that you can improve upon it and continue to work through it. I hope these little 3 videos helped. I will certainly most likely be making more, as well as I have quite a few more videos on factoring in and of itself. Lots of different methods to factor, so pick one that works for you. I don't go through all of them because I don't know all of them, but I will certainly work through, and if I get a comment that says, hey, can you try this one, I'll try to get to it as soon as I can. All right, thanks for watching.